Assalamu alaikum. Good afternoon, madams. Good afternoon, all of my friends. Hassan Mahmoud Zahid from Bachelor of Information Technology in Universal University. And today I'm to talking about I'm to discuss something. That one is how to solve the optimal solution. Use the linear programming and how to get the maximum point. Okay, so let's see. So this is the question. The question saying the factory makes two types of products A and B and sell them at a profit of RM 300 per unit and type A and RM 2 per unit the type B. And each product proceed on two machine M and N. Type A requires 2 minutes the processing time and M 4.5 minutes and type B required 3.5 minutes on the M 2 minutes, and the machine M and N available 8 hours 20 minutes and 10 hours respectively during the working day. How should the manufacturer allocate the production capacity to the two types of models so that he may make the maximum profit in a week? So now we are solve this solution. The first of all, here we have to identify the variable. So which one the variable here? So variable here, the factory makes two type of products. So the product A and the product B, the variable. So let's see, write it down. The variable B A R A I B A B, variables. Okay. So here the variable here is product A and the product B. So here let's see, write down x1 is a product A and x2 is the product B. So this is the variable here. So now we have to identify the objective. So objective here, the profit. The profit here is the RM 3 ringgit per unit and the RM 2 ringgit per unit. So identify the object. So object see the object okay object. So object here the profit here's the 3 and 2. So here 3 x1 plus the another one is 2. So 2x2. So this is the object and the variable. So now we have to find the constraint. Okay, let's see how to get the constraints. So here the constraint. So before we do the constraints, we can make a one table. So then we can understand very easily. So let's select one table here. Okay, let's the table here. So we are done here the variables, then here profit, then here we have to write it on the processing time. The processing times is one is 8 or 20 minutes and another one is 10 hour. So processing time, let's see, processing time, the M yes, C, and the processing time here is the minute, M minute, and then we have another processing time processing time, that one also minute. Okay, so the variable, the product x1, the product type A, and the second one x2, product type B, and the profit here we saw already 3, x1 is 3 and the product B is 2, and the processing time. So we can see here the requirements 2 minutes of processing time and M 4.5 minutes. Okay, so there is 2 and 4.5. okay, the second one type B requires 3.5 minutes and 2 minutes. So here the product type B 3.5 and 2, you see 2. okay, then here the limitation, so limitation here, so we can see here the time is 8 hours 20 minutes. So 8 hours 20 minutes, and then another one is 10 hours. By the this one we have to calculate in minute, so this one we have to convert it with hours, we have to convert the minute. So 8 hours, like 1 hour is 60 minutes, so 8 then 60. okay, we have to put the bracket here. okay, then plus 20 is equal is 500. The here is 10 multiple with the 60 equal 600. So here is the profit 3x1 plus 2x2, and the here after convert we got the result 2x1 plus 3.5 x2, and this one here equal the 500, and the here is 4.5 x1 plus 2x2 then the equal 600. So before we make the graph, so we have to calculate here this one, we have to calculate these two. So here let's see, 2x1, okay, just for a while we can copy this one, Ctrl C, put it here, control V equal false. So here if x1 equal to 0, so how is the x2? So x2 equal 500 divided by 3.5. So let's say how much we get from here. 500 divided by 3.5, so it will be 143. Yeah, 143. And the another one here. If x2 equal to 0, so x1 equal, if x2 equals 0, so we have to 2x1 equal to 500 divided by 2. So here result x2 equal 250. So here we got x2 equal 143 and x1 equal to 250. So we got from here x1 and x2 we got from here. And we have to see here we have a 2 processing time. So this is the 1 processing time and we have to calculate the another processing time. So this one we this one we keep here. So let's see, if x1 equal to 0, so 2x2 equal to 600 divided by 2, so equal is 300, so equal to x2 equal to 300. And when x2 equal to 0, then x1 should be the 4.5, x2 4.5, x1 equal to 600. So x1 equal to 600 divided by 4.5. So x1 should be 133 or something like that. Yeah, 133. So we got from here, so we got the number here, just the bracket. The first one is 300 is the x2 and we got the x1 is 133. So now we have to draw the graph. Okay, so now we have to draw the graph. So let's do here. You can just a little bit bigger. Okay, okay, this power. 3 4 5 1 2 3 4 5. So here this one is x2, and here is x1, and here is 0. So here we can write it down here. $100, then 200, 300, 400, 500. You see here also you can put 100, 200, 300, 400, and here 500. Okay, so first one we already got here. The x1 and x2 is 143 and 250. So 143 is the x2 and 250, that one is x1. So this is the x2. So x2 is how much? 143 to 250. So where I get the 153 here. Okay, here to here. Okay, and the one more is 300 to 133. So 300 to 133. So here is the 300 here, and 133 should be here. Okay, so this one 2x1 3.5x. This one is 2x1 plus 3.5x2. Okay, and this one is 4.5x plus 4.5x1 plus 2x2. Now like that equal is 500 here, and this one also we have to put here 600. Okay, so now this one So now we have to decided the corner point or the feasible area, corner point and the feasible area. So this is you can see here downstairs, this one is the feasible area here. And if here like the corner point is 0 0 0 0 here, and we have to see how many corner points here, and we can see here is 1 2 1 1, this is 1, this is 2, the 2, this one is 0 to 143, this one 0 0 to 143, it's 143, yeah, next to 143. And this one is the first corner here, this is the second corner, and this is the third corner we decided later. So this is the fourth corner. The fourth corner here is 133, 0 to 133. So let's write down. Zero to 100 x1 133, yes, 133. And this one is the feasible area here. So now we have to calculate the profit or maximum or the minimum point. So the maximum point, how we have to calculate? So maximum, let's see, we make the another table here. Okay, 1 2 3 4 5, let's take 6 table here. So this is the point, your empty point, and here the z equal to the profit. This is, you have to write it on here, the profit. So we know the profit here is 3x1 and 2x2. The profit here 3x1 and 2x2. So let's write down 3x1 plus 2x2. So the point 1, yeah, the point 1. So we get the point 1 is the 0 0. Of course the point 1 obviously 0 0 0. Okay, so how we have to calculate here? The 3 into, so x1 is 0 0 plus plus 2, here x2 also 0, so equal 3 into 0 0, 3 2 into 0 0. So here the answer is 0. Okay, then number 2, number 2. So second corner we get the, oh, one more things, we didn't identify the third corner here, so we have to identify the third corner also here. So here is the third corner. So third corner should be 100, and here is 150. 150. This is the number. This is the third point. So second point here, 0 to 143. 143. Okay. So here 3 times 3 into, so x1 is 0, so 0, then plus 2 into 143, so x2 is 143. Okay, so equal, we got the result 203 multiple 0 0 and 200, yeah, 286. So here is here you get the 286. Yes, 286 we got here, and the number 3 here. So third corner, here how much? Here is 100 and 150. Okay, so let's do here is 3 multiple 100 plus 2 multiple 150. So here is x2 is 150, so equal 300 plus yes, should be okay. So 300 plus 2 multiple this also 300, so equal is 600. And the number 4 we got 0 until 143. Okay, so here 3 multiple x1 is 0 plus 2 multiple 133. Okay, so how much? 3 multiple 0 3, so 266. So here we already got the maximum point here. So which one is the more minutes and more take time? So you can see here the first one is 0, second one is 286, third one is 600, and the fourth one is 266. So which one the maximum point we can see easily. So this is the maximum point here. Maximum point. So this is the maximum point here, and maximum point, and this is the optimal number as well. So okay, and so this is our maximum point, and this x1 equal to 100 and x2 is equal to 150. This is the optimal point. So you can write it down here. x1 is 100 and x2 150. This one is optimal number. So this one is the optimal number we got from here. Okay, so this one we can, this graph we can do, we can use the another apps. That one called is Thora, or we can use we have some more of linear programming apps. You can use that one also can, but normally I prefer the Thora. That one is very easy for me, easy for you also. So now I want to show just one. I just note it here. 2x1 plus 3.5x2 500 and 4.5x1 plus 2x2 600. The profit 3x1 plus 2x2. Okay, so now let's start Thora. Thora. Okay, we start the Thora here, and here the linear programming. We have to select the linear programming. After that, go input in the screen. Okay, so solve the first problem here. So we write it down here. Then variable. So how many variable we get there? We got two variable there. The product A and the product B. So we write it down two variable. And how many constraint we got there? We got two constraint there. So we write it down two constraint, then enter. Okay, so we have to write down the variable name. So variable name is product A, and x2 is product B. So the maximize, so maximize mean the profit. So we get the profit there is the x1 is 3 and the x2 is 2. Okay, the constraints. So we got the two constraint there. So the first constraint is 2x, x1 is 2 and x2 is the 3.5, right? Yes, 3.5, and that one is less than 500. And the second constraint, that one is 4.5x1 and the x2 is 2, and this one is 600. Is 600. Then you have to solve the menu. So if you want to save here, you can save here. So I don't want to save now. So you have to click here to solve the problem and the graphical. So we have to see the graphical here. Okay, go the output screen. So here we got the graphic chart here. So we have a two constraint here, the constraint 1 and constraint 2. So if you click the constraint 1 here, and you can see the profit also here, the 3 and 3x1 and 3x2, and the two constraint 2x1 and 3x2x1 3.5x2 and the 4.5x1 and 2x2. So if I click here, you can see the already graph already here. And then the second one, if I click here, okay, so we got the result here. So here we got the 3.1 is here, another one is the second corner here, the third corner here, and the fourth corner here. Okay, so now we have to see the solution. Sorry, I write it down one more time. Case study 1, 2 variable, 2 constraint, product A and product B. So the profit is 3 and 2, and the constraint is 2, 3.5, that means 500. Then the second constraint is 4.5, then 2, and this one is 600. Okay, then solve the menu. So I told already everyone, if you want to save, you can save. If you don't want to save, I don't want to save, so I just write it down now here. And the first time we saw the graphical, so we already saw how is the graphic showing. So now we have to see where we see the algebraic. So we click the algebraic and you can see the final solution. So click the final solution and go to the output. See, we got the final solution. So you can see all of the solution here. So it's not so hard, not so difficult. If you just exercise, then you get the result. So that's all today, all of my friends. Thank you so much for watching my video, all of my friends. So bye bye, thank you.